Hi everyone, so today we're going to be going over this data recovery case that was unsolvable by another really large company, actually an international company that worked on this board prior, that tried to recover the data. They told the customer it was not recoverable and the customer sought a second opinion and sent it here. So kind of a spoiler alert that it's already fixed and working, but it was still an interesting case. So my message to consumers is that when you see these big companies, don't always trust them. Like what I'm trying to get across is, if you see my website and then you see this other website that says they've been in business since 1985 and that you see they're partners with Apple, HP, Dell, EMC, all these companies, if you see a small business and then you see their large business, if you had priceless data on your laptop like this one has on it, you're probably more apt to go to the business that looks so official and has been in business for so long and is partners with all these large companies over a small business, when in reality it's kind of the opposite. You know, when you see large companies, generally they don't put the same level of work in. Generally their technicians aren't as trained. I'm not speaking for everyone, but I'm just saying a lot of times this is the case. And I think this is the case here, especially with the work that was done on this board. So this case was particularly interesting because they were basically told it can't be done, that the data can't be recovered on this board, and it was actually wasn't even that intense of an issue. But not only that, they kind of butchered the rest of the board. They removed stuff that shouldn't have been removed, and they kind of made the board a previously fixable board for full functionality. They kind of made it into a data recovery only board. But what I mean by that is the Thunderbolt circuit, a lot of just the other components on the board, a lot of like non-essential stuff was removed and kind of butchered it to a point where it can't be repaired. And if it would have got to a different business first, like Minor Lewis's or Anthony Jabari's or John Borelli's, anything like that, we probably could have fixed it in full functionality first. So enjoy the video, and thank you for watching. Okay, today we have an A1932 in for data recovery that had a liquid spill. So let's go ahead and take a look at this. First thing we're going to do is plug in our USB amp meter. Let's see what this reads, what voltage and amperage. So it's at 5.17, 25 milliamps. It should switch to 20. It's at 20, but 0.3 milliamps, 0.7. So this is actually reaching 20 volts, but it's not turning on. So there's something else going in the power up sequence. So let's go ahead and take the bottom cover off and find out what. Okay, so just looking at this, I could already tell somebody's been here because the shield has been removed from around the T2 chip. I see some flux around here, so this has been screwed with. And yeah, this is why you don't... Okay, public service announcement. If you care about your data, please, if you care about getting your data off of something, please bring it to a reputable repair shop prior to this. Most likely this is going to be sloppy seconds and it's going to be a nightmare. So if you care about your data, please don't try the guy that does it for $75 over a reputable repair shop. If you don't want to send it to me first, fine. Send it to Lewis, send it to John, send it to just somebody competent. Because the sloppy seconds are never fun. So let's go ahead and take out the screw in this, or take out the screws. And the screws appear to be, let's see, do I have the right screwdriver? Yep. And the standoffs are stripped in the board. That's going to be fun. Again, yeah, the standoff, this is probably the worst screw for the standoff to be stripped on because it's just spinning in the board. It's just spinning in the board, and there is no way I could jam a screwdriver or anything in there to stop the standoffs from spinning. So yeah, this is already off to a dire start. I can't stress this enough. I'm sick of dealing with this. It's happening more and more and more. The shops that screw with stuff before sending it here, and it's just getting old, and I'm going to have to put a stop to it. You know, if you want your data, you're not going to do this. because it makes it 10 times harder than me when somebody else messed with it. Because then you take a fixable issue into something that's not fixable because somebody messed with it. It just makes my job 100 times harder, and it's, you know. Here's the thing. If you're going to be a board repair shop, if you're going to work on boards all in. Don't fix something halfway, give up, and send it to somebody else. If you start fixing it, finish fixing it. My main concern isn't the board. It's getting this darn screw out, because this one screw, you guys will see in a second. I will show you guys in the microscope once I get the rest of the board screws out, all the stuff unplugged. Maybe I can jam something in there in that corner to stop that standoff from moving. So here's, okay, let me picture this. So if you look on these new boards, you have the board. So here's the board, here's a screw, and then there's a standoff that's threaded into the base of the computer underneath that screw. What happens is this standoff starts spinning in the case. So you're spinning the screw with the standoff in the case, and then it becomes to a point where you're not going to be able to get it out. It's really annoying. It's a really stupid design. I don't know why they switched to that, but they did. Probably to save on material costs. So when this happens, normally you have enough clearance, you could jam tweezers in there, hold on that standoff, and it'll stop spinning enough for you to get the screw to come out. Then you could tighten the standoff later. In this case, we don't have room because there's this black thing around here. You guys will see in just a second. Okay. Microscope. Alright, so what I'm talking about is this right here. So you see this? Normally, they don't have that black ring around it. Normally it's like this over here, where I have enough clearance where I could put my screwdriver in there and stop that standoff from moving. But over here is much, much different. So what I'm going to do is try and slide the board and poke my finest tip tweezers in there with the screwdriver and try and come it out and try and bring the screw out. Where I need my super fine point tweezers, and I don't know where they are. Let's see. They up here? Nope, they're not here. Here they are. Perfect. Okay, so there's no guarantees on this. It may not work. We're going to try. So, let's see. I'm holding it, putting pressure. Now, I'm saying I'm putting a lot of pressure on it because I don't want it to move. I got to move this outside of frame just for a second because I can't fit the screwdriver under the microscope head. And are you going to thread out? You are almost threading out. There, you threaded out with the... It threaded out with the standoff, which is okay. Now let's see what nonsense is on the other side. Because I already see nonsense on one side. It usually means nonsense on the other side. Is this... I just see shields removed. I don't see anything major yet, but let's go ahead and have a look under the microscope and look at this awful soldering over here. Don't do this, please. I'm already saying it right now. We're not going to be accepting any more of these from other stores. If you mess with it, then you finish it. Look at this. Look at this junk. What is this? Come on. Look at that. Looks like you took the shield off of something. You took the shield off. There's knocked off resistors. There is They took the shield off. Is this an underfilled chip? Luckily, it is not. Good. Yeah, so this is data recovery only. Yeah, I'm just going to get this to turn on. This is for the CPU. So this is one of the chips for the CPU. It's a MOSFET. My guess is our issue is going to be here, because these these caps right here, these are just for Wi-Fi isolation, just to reduce noise. We don't need these, just go away. Don't need them. They're not important. There's stuff that's been removed here. There's a probe point there. There is a cap here. We don't need this either. There's awful soldering here. Look at this flux. This isn't even soldered. What did you do? It's like, come on. Look at this. It wasn't even soldered. This is all stuff I presume for a JTAG connector. These are important right here. These resistors right here are important. This is probably why it's not turning on right here. So there's a couple of resistors here. These are part of the SPI termination resistors, I believe. They are like that on most boards. So, they're like this on most boards. Whoa, my tweezers got super messed up. And these are my favorite pair of tweezers. On most boards, including the older MacBook Air boards, these two SPI termination resistors are important. So let's go ahead and see if this is the case on this particular board. So first, yeah, you know what? Okay, no, we'll check that first. This is an 8200085 something or other 801521. So this is a 2018-19 MacBook Air. And let's see, display capture. Alright, so let's find this connector. So we are on this side of the board. Now this is some connector for, yeah, it's a JTAG for the USB. Alright, so these I don't think matter. This is for US Thunderbolt something or other. I don't care about it. It's not that important. So let's continue on. I thought it was a JTAG, but it's not a JTAG. So let's look on the other side. But we have a lot of nonsense here. That's probably not important right there, so we're just going to ignore it. Yep, there's your screw hole. Over here, okay, so this looks pretty nasty. These, no, those are original. Some of these have the Z variant, CD3215, C00Z variant chips. This doesn't. Let's see what this chip is. This was clearly ultrasonically cleaned. Very clearly ultrasonically cleaned. And there's just a mess everywhere here because, yeah, somebody messed with it. So this chip over here is Thunderbolt Power Enable. Okay, I don't care about any of this stuff. It's Thunderbolt Power Enable. So due to the amount of missing stuff, I am not fixing this board for... due to the amount of nonsense on this, I'm not fixing this board for use. I wasn't the first one that got to it. There's knocked off stuff everywhere. There's just too much stuff to do. Too much stuff to do, and it was screwed with. It's simple as that. It was screwed with. So I'm going to remove everything that looks funny and try it, because sometimes these intermittent shorts, you can get an intermittent short from a component like this that will cause our issue. So see anything else on this side looks funny. Yeah, this stuff, this nonsense. I'll leave that, at least it's soldered. My guess, this is going to be our issue right here. Yeah, that smelled burned. Yeah, this was probably our issue. Yeah, look at that. That looks real nice. Let's clean this up. Okay, let's take a pause and talk about this for a second. I reached out to the customer about this board, and they stated that it was worked on by a very large data recovery company that's been along for a long time. Not drive savers, but take hint. They've been around since 1985, or actually 1972, but started doing data recovery in 1985. This is disappointing because multiple reasons. The standoff screw that was left in here like this, and secondly, just the bad soldering and the bad work. The MOSFET for PP5V G3S was corroded, as you could see. It was left on there. They replaced the output caps, they replaced the coil, but they didn't check the input of the circuit, which was completely corroded and destroyed. So I'm pretty sure that's why this isn't turning on. We're going to continue on this. I've done a little bit of work since the last recording, mainly just cleaning up that pad, but other than that, it's still exactly the same. So we're going to go ahead and take a look and fix this and get this person's data back. This really disappoints me when I see this from big companies, because companies like this one, consumers see as more trustworthy in their eyes because they're a large company. They do a lot of work for big companies. Even Apple recommends them in some cases. So in instances like this, it's really disappointing to see this because the consumer would see them as trustable, get their board completely destroyed like this, and then they don't, they think that's the end of it, and that's not often the end of it. So let's go ahead and continue working on this. First, let's actually go ahead and have a look at the schematic at this circuit to see what it does. So here's our circuit right here. Let's have a look at the board view. So let's switch over to our display capture and go to our board view and schematic. So we can see right here that the corroded pins that we had were PPVin G3 P5V G3S, which is the 5-volt rail. For a bunch of things on this that are important, we can see this is the MOSFET. Now, what they did, they replaced the inductor and they replaced these 3 capacitors for the output. Now, what the heck is that going to do when you don't have input voltage to the chip? This cap, I believe, was missing as well. I think that was missing or corroded. I have to look at the previous recording. This resistor was corroded. Again, there's so much stuff that's corroded that's going to cause this not to work. And if you leave this on here, I don't know why you're messing with stuff on output if the input of the circuit is no good. So looking at this, we can see that this powers a lot of important stuff. It powers input for the CPU MOSFETs. It looks like these new ones on these airs are running off of, no, they're still off of 12 and 5. But it's very important for this to work. If we don't have power here, then a lot of stuff on this board is not going to work. And how this was missed, I have no idea. It even has inputs to the CD3215. So a good majority of this board is not going to work if we don't have the input circuit there. So let's go ahead and get a replacement MOSFET. It looks like these are going to be, let's see, what's the number on these again? 58873D. So we can get this from a 875 here, I believe. So here's an 820000875, and we could take this guy from here. 58873D. Believe I can't really see that, but we're going to go with that one. Let's go ahead and clean up these pads a little bit better and put some solder on top of them so we have something to solder the chip on. And then we can replace the output capacitors as well, and that corroded resistor that was here that had no pin left. If you remember, look at this resistor and there was simply no pin here. There was nothing left there. My next question is, was the controller damaged? If the controller was damaged, then the chip will die again after we replace it, so that's also not good. So these pins are fairly of a high thermal mass, and you can see there's kind of some junk on them. We have to switch to a bigger tip, but right now I just kind of want to scrape all that off because it's no good. Whenever you get stuff that looks like that where it's just not sticking on the pads, then you need to switch to a bigger tip, but I think this should be okay. A lot of times it's not actually that there's not thermal mass, there's just so much oxidation on the pads that it's not going to work. but sometimes a bigger tip will help. So let's switch to our BC2 tip, which is bigger, has a much higher thermal mass, and will allow us to solder on these pads a lot better than we would with the small tip. So watch this. Let's let it heat up, because it's still too cold, obviously. See that? Much better. Now right here, we should be able to do the same. Get some good solder on there. That's good, because it's all connected. One last pin right here. We're good to go. Put some on that center. Just like that, and we're good to solder a chip on. Alright, time for some fresh flux. Let's go ahead and pull our chip from the donor board. Make sure we put it on the right direction, because that would not be good if we put it on the wrong direction. Pretty sure it goes this direction, opposite to the other one, but we are always going to double check. Chips have alignment marks for a reason. So you see this dot? Well, you probably can't because I can't see it. Let's focus our microscope. So you see this dot right here? In the corner? Oh, come on, go into focus. Microscopes. There's a little dot in that corner there. So if you look at our board view, pin 1 is always going to have a red dot on it. So this is on the board view. So let's go to the board view. So where's our chip? Where's our chip? Okay, is my brain broken? Here we go. So see this dot? Pin 1, pin 1. So that dot is going to be right there. That's how you tell. So any kind of chip like this, if you don't know which way you put it on, I've had places that have put chips on backwards or whatever. If you're ever confused about something or which way the chip goes, let's take this guy for example, right? There's always going to be a dot or a plus sign or another marking where pin 1 is supposed to be. So it's, you know, kind of hard to put it on the wrong way like that. So let's go ahead again, microscope, put this guy on, put that resistor on, replace those output caps because those are not going to be any good. They soldered on top of corrosion, which is no good whatsoever. You can't solder on top of corrosion because it's not going to, it may conduct a little bit of voltage, but it's not going to conduct the current you need. Anytime you get a pad that's corroded like that, it's not going to be able to carry the current that you need for the thing to work. Picture it like a kinked water hose. Yeah, like you may get some water out of the end of the hose, but it's simply not going to be enough pressure, enough volume to do what you want. Okay, looks like R7666 is a... Where are you here? R7666. Where are you? Is a 1 ohm resistor. So let's find a 1 ohm resistor on a compatible donor board. Looks like R7733 off of a 820000875 will work just fine. Alright, on this resistor it's going to show up actually in the same exact circuit on another board. So let's go ahead and pull this little guy off of the donor board here. Off of the donor board onto the patient board. Come on, go into view. That's in place. Now it's time for that bootstrap capacitor. I think it was a bootstrap capacitor. Very important for a MOSFET if you want your MOSFET to last any considerable amount of time under load. I believe that was a 2.2 microfarad. I could be wrong. Let's see. Back to the board view we go. Where are you? 1521. And your CPU. That was this one, C7660. Which was a 2.2 microfarad. This is kind of important for the input of the chip. It is and it's not. It's just to prevent any excess ripple. The main thing are going to be these 33 microfarads right here, which are hopefully present, but then again, never know. So let's find a 2.2 microfarad on another donor. Let's see. Let's just search for one. 00875. Might as well show some of the process. Let's see. Is it going to be this one? Nope. Alright, let's search for a 2.2 microfarad. Where's our input? Where's our input here? Here we go. Right here. 402 C7722. And that's right up here. So let's go ahead and take this off the donor. Alright, add a little flux. Now you see how that one pin is like all falling off? Here's what we're going to do. We're going to solder this on. We're going to clean a little bit, and then we're going to scrape and build a little solder bridge. So just clean it. See, it's still making contact, but why risk it? So let's zoom in. We're just going to get our tweezers. We're going to expose a little of that copper, and then we're going to be good to go. And then we're going to test it. There's a lot of stuff missing off this board. I doubt it's going to work the first try, but if it does work, then great. But I'm not holding high hopes because of the amount of stuff that they removed off of this board. Okay, that should be good for that solder bridge. Flux always helps in this situation, but of course, when you don't want a bridge, you'll get a bridge, and when you want a bridge, you'll have a difficult time getting a bridge. Which is the rule of soldering. You want a bridge, you'll never get one. But if you don't want a bridge, then it's always going to be there. If for whatever reason you don't get a bridge right away, switch to a different tip. You could scrape a little bit too and add solder. So in this case, it's not even tinning on the board, so I need to worry about getting that tinned on the board. So I kind of feel like that tip didn't have good contact on the board, so I'm going to use this other tip right here, which will allow us to scrape a little bit better. See that? Now we're tinned somewhat, and we have a bridge. Let's make it look prettier though. We want nice good contact. And there we have good contact. The solder joint broke on the other side, so I'm going to give it a little reflow again, just to force it into place. And once it's liquid, perfect. See that? Went into place. Or not, because it wasn't in focus, but you get the idea. Moment of truth. Let's go ahead and test it. So, USB amp meter. Still too hot. Let's go grab a DC in board. Actually, take that back. Let's go ahead and take care of this mess right here. So we see a lousy flux has been used. We see that there's... What are you doing? Come on. You can do better than this, major large company. Okay, let's get rid of these caps because these are clearly no good. We're going to direct heat away from the NAND. That coil, although ugly, is probably fine. Unbelievable. Soldered right on top of corrosion. So this is like, it's not even, this is like basic rules of soldering. You don't do this. If there's oxidation, you get rid of the oxidation first. This is pretty oxidized. but you shouldn't just put a cap on top of that. So here's how you get rid of this. This is severely oxidized, so you need a good flux that is good at removing this. NC560 is very good at this, so let's put a good amount on. Let's get our iron, make sure our iron is nice and tinned. We may need a bigger one, but we should be able to scrape. So we're just going to scrape. We want to get rid of all of this junk on these pads and make them shiny. Then we're going to wick it again and make sure we didn't solder on top of corrosion. But if you have a good flux, the flux is going to do most of the work for you. Like, see that? Most of that is gone, and that's going to be sufficient. This one still needs some work. Let's get rid of this thing first. And I should be using the fume extractor, but although not very pretty because we took off some of the conformal coating, now we have a nice surface to solder on top of, and we should have no issues there. Let's clean the other side. Perfect. Let's clean these pads up with a little alcohol. See that? Now we actually have, so even if they put these caps on there, they wouldn't have been, there was nothing for them to solder on top of. It was basically just solder sitting on top of corrosion, and that's just awful. So there was just major oxidation there, and now there's not. So this is good. A little bit minor, but it's not too bad. So this is perfect to solder on top of now. Sometimes even you'll get a tin, then you wick it, and it's completely gone. So due to the nature of this board, we're not really going to worry about much of this stuff. It's just too bad. And the main concern here is to get the client's data off and not really worry about the superficial stuff. After we clone the drive and stuff, we could worry about this, but in the meantime, we just need to get it to turn on. Grab some new caps. Alright, let's go ahead and put these caps on. We're going to improvise a little bit on one of them. 150 microfarad should be fine for this circuit. We're going to use two 220s and 150 microfarad because they're strange. And you blew away. These 220 in this format is kind of strange. It's not really found on any other boards. So sometimes you just have to improvise. I just want them down, just barely, for the time being. We'll make them pretty later. So let's grab the other one that we need. I don't see this board being such high load that it's 150 isn't going to work. It's a little air board. 150 on one of these should be totally fine. You're all soldered now. Now for the real moment of truth. Do you turn on? So let's just let it cool down. It's probably kind of warm right now, and I don't want to start the circuit up when there's such high heat. One of these USB ports is bad to note, but plug it in. Let's see what we pull. Like I said, I'm not holding high hopes, just simply because of the issues with the what do you know? You are turning on. Well, are you? Are you turning on? What are you doing? 22, are you cycling? 39, you are booting. That is booting current. Let's go ahead and put this in a enclosure, and let's see if I fix the board, because I would be really happy if I fix the board and save this person's data after they were told it was gone by a large data recovery company. Let's grab the enclosure. Alright, for the moment of truth, let's plug in our USB-C adapter. The screws are out of the little plug, so let's push it in so it plugs in. Lights up. Let's open the lid. It's 5 volts. Our screen is plugged in. Now we wait. Do you give me Apple logo? Do you do anything? It's at 0.4. So there's a little warmth from the CPU. Let's try it again. Is the screen plugged in all the way? Yep. Alright, let's try plugging in the fan, the trackpad, speakers so we could hear it, and a little audio board. Let's just plug most everything in except the battery. That's the only thing I don't want plugged in right now. Here's why. This USB connector doesn't really fit in that well. Let's try something. Let's get rid of this one. We'll try this one again. This one's kind of messed up, so I'm kind of reluctant on it, but let's try it again. There, that's plugged in good. Five volts, 12 milliamps, 25 milliamps, 22 milliamps, 20 volts, 0.7 milliamps, 0.4 milliamps. Let's give it a second, because a minute ago it went up to 33. But it looks like it's staying on 0.4, so it's power cycling technically. At least I believe it's power cycling. Yeah, it's staying up. Oh wait, no. 0.13, 0.20, 0.19, 0.34, and the fan is spinning. And we have an Apple logo. This is fixed. So let's cover this. Does this actually boot into an operating system? So there's a lot of stuff missing off this board this other company removed. So it may act a little funny, and that's probably why we got the initial power cycling thing. So in a situation like this, what I'm going to do is immediately clone their drive and get the data off of here just in case the board does fail. But I think this is recovered. We will know if we boot into a user profile. I want to cover it because I don't want to reveal their name. It may boot into recovery mode as well. That's another common thing we see when they boot slow. So I'm just going to hold tight here. Whenever they boot super slow, it's usually going into recovery mode. The fan is running fast too, which typically means there's a sensor problem somewhere, which also could mean it's going slow. But again, the amount of stuff that's removed, that really is not out of the question. Almost at the end. Come on. Boot into an OS. Waiting. Alright, looks like we're here. We should have a cursor here. The screen just brightened up a bit, but it stayed stuck. We have Taptic on our trackpad. Come on. These new ones will act funny, and there's, yeah, with a sensor error. Alright, you know what? I wonder if this needs a battery plugged in to boot. Some of these new ones are really weird with the battery. So let's plug in the battery just for the heck of it and see if it boots. But at least we know now. At least we could be able to boot into recovery and clone the SSD if needed. Plug it in. So the battery is now plugged in. You can just go ahead and hit the power button. Probably won't boot because the battery's probably dead. Plug it in again. Alright, let's see if it does the weird power cycling thing again. We're at 5.25 milliamps, 20.7 milliamps, 0.42 milliamps, 0.40. So it's starting to charge the battery. 0.52 milliamps. Fan is spinning. Or the fan cycled. Apple logo. So we're getting good here. Progress bar. It's going a lot faster this time. And the fan is not racing, so it was the battery not being plugged in. But the real question is, do we get into an OS fully? To me, this seems like it's starting into recovery mode. When they do this, it's usually starting into recovery mode. Usually. Would really suck if there's some weird fault with the SSD circuit or something. But I really don't think so. I think we're just starting into recovery. Almost at the end again. Are we going to switch over? And will the screen go bright? So whenever you see the screen like change colors or go bright or whatever, that's when the GPU switches off of 256-bit color to whatever it has. I don't know exactly. Yeah, this is booting into recovery. So we're just going to give this a minute. And what do you know? We have a fixed MacBook. I don't want to show their name, but you can see this is working fully in their OS. It's booted into their OS, and this is fixed. So yeah, this was a nice case, and I'm glad that we were able to get this recovered and get their data back after being told that it was not recoverable. Thank you for watching, and I hope this video helps you.